All right, welcome to the lunchtime video. A little bit of a late start today. I just was wrapped up with something with work, so I can put in the extra 10, 15 minutes, whatever. Later today, I've got a half-hour meeting at 1, so from 1:30 to 2, I can just put in an extra 15 minutes on this video. So the last video, I think I threw in the towel on trying to get a VPLS instance to have resolution for those OL connections. When I did show VPLS connections, I had the remote connections in OL, but the reason for that is I was following a pretty poorly written lab. There's better labs for doing that same thing. This was specifically for VPLS multi-homing. So it wasn't a lab just for VPLS connections themselves. So VPLS is going to be a topic that I cover on its own later. So I figure since my goal was to learn about BGP multi-homing, which I couldn't find any information about, I'm just gonna leave this at bay because it turns out I wasn't even using BGP signaling for this VPLS. So I really wasn't even doing anything relating to BGP at all. So unfortunately, that means kind of moving on without practicing BGP multi-homing because I don't know what they mean by that. I did do some reading about BGP multi-homing. I found something online and I read that in one of the videos. So I'm gonna call that good. And this video, we're gonna move on to a new topic. So I will share my second screen. Okay, and the first thing I would like to do is verify that I uploaded my last video. And you can see I've got this really nice block site. When I first started my new job, I found myself getting distracted by news and all that sort of stuff. So I set this up to make sure that I can only catch up when it's an appropriate time for me to do so. But right now I'm on my lunch break, so I will unblock those sites, and then I will switch over to my account for this. Perfect, and I will go to my channel, my videos, and it should be the third one, or yeah, the fourth one. Okay, so I did upload it. That's kind of the way I would like to start all these videos. I'd like to have them in at least 3 parts. The first part, just a brief of the last video, as I've been doing. The second part, I share my screen, then I upload the previous video. And then the third part, I make a plan for what I want to study. Fourth part, I implement that plan. It's kind of how things have been going. But you can see I've got everything ready to go. Now, last video, I did come up with a plan because I tallied them up, and it turns out that I've got 40 topics to get through, and I've got about 60 days to get through them. So this kind of study is, I think, working pretty well for me, but I might need to do some memorization study, some sort of thing in the 2 weeks beforehand. So I might need to change up my game and really focus on memorizing some stuff or do a different kind of study than this. So I came up with a rule in my last video where I try to do 1 topic a day. And if I don't get through the whole topic for whatever reason, I just gotta move on, unfortunately. So I'm gonna try to adhere to that rule. So it does mean that I'll have more than 1 video a day. I'll have 2 videos, the lunchtime video and the after work video. But unless I study more in that day, maybe I can do an evening video, something like that. That's the only practice I will get. So I might need to add a 3rd study session throughout my day. I can do a lunchtime, I can do a after work, and maybe I can do an evening, something like that. That really, I think, makes sense for me to do. It's going to be, of course, not fun to be studying so much, but the test is in 2 weeks, so it's really kind of warrants that sort of intensity at this point with how close it is to the test. Okay, so this one should be pretty easy though, because it's route confederations, which is just a really well-known, well-studied topic. So we should have some really good luck with finding help documentation for this. Okay, so we'll start off with the classic strategy, help apropos confed pipe match help. There we go. So now we've got help topic BGP examples confederations. There we go. And we've got a whole lab. Perfect. So let's try to figure out. So yeah, let's take this whole lab, put it in like Notepad++, and oops. Okay, well, this terminal sucks. Okay, there we go. So now we'll put this in Notepad++, and everything you see me doing here, I will be able to do during the exam. So this is not something that will kind of, I'll be relying on the wrong thing. I won't get this during the exam. You know, I'm not setting myself up for failure doing this. In fact, I'm setting myself up for success, because undoubtedly when I run into a subject I've never seen before or I'm comfortable with, I know how to use the help. Okay, so let's read all about it. Within a BGP confederation, the links between the confederation member autonomous system, ASs, must be external BGP, Ebgp links, not internal BGP, IBGP links. Similar to route reflectors, BGP confederations reduce the number of PE sessions and TCP sessions to maintain connections between IBGP routing devices. BGP confederation is one method used to solve the scaling problems created by the IBGP full mesh requirement. BGP confederations effectively break up a large AS into sub-autonomous systems. Each sub-AS must be uniquely identified within the confederation AS by a sub-AS number. Typically, sub-AS numbers are taken from the private AS numbers between 64512 and 65535. That's 16 bits with all ones. Within a sub-AS, the same IBGP full mesh requirement exists. Connections to other confederations are made with standard Ebgp, and peers outside the sub-AS are treated as external. To avoid routing loops, a sub-AS uses a confederation sequence, which operates like an AS path, but uses only the privately assigned sub-AS numbers. Typical network using BGP confederations shows a sample network in which AS17 has two separate confederations, sub-AS 64512 and sub-AS 64513, each of which has multiple routers. Within a sub-AS, an IGP is used to establish network connectivity with internal peers. Between sub-ASs, an Ebgp peer session is established. To quickly configure this example, copy the following commands, paste them into a text file, and remove any line breaks. Okay, so we're just going to be configuring everything here. So there are some pre-requirements, but we should have no problem setting those up. Okay, so let's just repurpose our existing topology here where we've got 5 routers. And unfortunately, they're not going to give us all of everything we need, but we'll be able to do these requirements, and we should be able to just come up on our own with what everything is needed. Now, we won't need these CE/PE roles anymore because this is not a VPN. We're talking about internal to our network. So these are all going to be PE or P routers that we're dealing with. So we'll just call it, we'll just number them A, B, C, that sort of thing. Okay, and I can get rid of all of these links as well. Not the ones connecting the control plane to the forwarding plane, of course, just the ones connecting forwarding planes to each other. Okay, so now we're going to rename these. Now, it's not going to be exactly following with what's there. We're just going to use that as a guide and just configure this. I'm just going to configure this myself because that's the way it's going to be during the test. Not everything's going to be laid out. So I'm going to be doing a similar thing. Perfect. Okay, so now let's, so I think the topology can be pretty much however I would like it to be. I think I'll just, so now it's essentially going to be like a route reflector, but quite a bit different. But it's another strategy you can use aside from route reflection. So for this problem, and the problem is scaling up BGP, you have a choice. Your choice is either route reflection or route confederation. So we already did route reflection in a previous video. Really easy. You just have a dedicated route reflector device that serves only for that. And then you need a cluster ID and you need neighbors to every other device. So you're going to have a whole long list of neighbors. But on every other device, you just have a single neighbor to the route reflector. So, you know, clearly there are advantages, disadvantages to each. Perhaps one disadvantage to the route reflector is that you do need a dedicated device to serve as a route reflector. Here, I do not think you need any one dedicated device. So if you don't want to just waste the device being a route reflector, route configurations are probably a better option. As far as I understand, confederations are a lot more difficult to set up though. So much like other trade-offs like LDP and RSVP, it's often a trade-off between how simple is it to implement and maintain versus how much control do you have over it. So confederations, you've got more control, but they're more difficult to configure. Route reflection, you're just going to point everything to one or two devices. And it might not necessarily be a trade-off in control too, because I think both are pretty darn toggleable. Okay, so oops, it looks like I did these backwards. So I'm going to change this to E1, and then change this to a lowercase e. Okay, and then change this to an uppercase E. All right, and then I will I'll just link them all together. So I'll probably just do a line because it's easier to think about the links that way, left to right. Okay, so now we've got 0 going right. Oops, it looks like I actually screwed it up. Let's have 1 going right and 0 going left. Okay, so 1 is going to go right, 0 is going to go left. 1 right, 0 left. 1 right, 0 left. 0 left. Okay. So now let's blank out the configs and keep the important parts, the host names, all the kind of base config, and then set up descriptions. So unfortunately, with all the labs set up, you can see that I've got to do, really the time I'm getting to study is quite limited. So that's a problem. But I don't know what the solution to that is. All right, A is good to go with the base configuration. We've got the description, just to make, I like descriptions. Oops, and I forgot the, well, yeah, you know what, I kind of like that kind of description, so I'll change that. All right, so now moving on to B. Okay, so I've got my help helper script on there. So things are a bit out of order. Oops, so I never did the delete. Yep, that's kind of my poison when I don't do the delete. Or my Achilles heel. Yeah, forgetting to do this is my Achilles heel for sure. So, but we've got the hostname good now, so I won't need to go back and edit that. We've got this. Okay, but I will need to add these, but luckily it's easier now since they're what they need to be. Okay, so now after I do that check, oops. Perfect. All right, moving on to C. Okay, and I'll remember to not succumb to my Achilles heel. All right, and now I can start adding the config back in that I want. Okay, that looks a lot better. Oops, I'm actually missing one line. There we go. Okay. Two more. Excellent. Now it's time for E. Okay, so we're good to go. So lab isn't going to kind of make things super easy, which is good because I want the practice. So the first thing we're going to need to do is configure the network interfaces. So let's do that. Okay, and we'll just use /30s like this. And let's start with that one so it looks a little bit nicer in the table. Okay, and these are going to be external peering sessions. So we're just going to peer to the physical interface as is typical in external peering sessions. So we won't need a loopback address necessarily. I'll leave it out now and then add it if it's needed. But it looks like in step 1 and in step 2, it won't be needed. All right, so let's leave that open. So we can go back and reference that, but move on to part B. Oops, and I might have configured the wrong. Nope, I configured it right. Okay. All right, one final router. Perfect, everything is good to go. So the next part will be configuring external peer sessions. So we can see an example here to help us do that. So unfortunately, I can't, this is a limitation of this help menu, but I did create the help helper in the last video. So let's actually use the help helper and see if I can pull up that configuration. I just want to see how useful it is for me to memorize the script and use it during test day. I have a feeling it'll be very useful. But we're going to need to go to var db scripts op, and then we'll need to do vi helper.py. Okay, and then we'll need to go here. Oh, need to add an I in there, so I will do a quit. Oops. Okay, and then okay, we need to add the I. There we go. And then I'll add the second part. The script here, perfect. Oops, and it looks like I did forget to change. Yeah, because I got to change it to BGP, and then I got to change the search string to this. Now it'd be nice if I could not have it be reliant on this. In fact, I don't think it has to be, because I can just do. Yeah, I think I can change it to not be reliant on the kind of help apropos I decide to use. I don't think that would be too hard. Okay, but let's first see if this is good to go. Okay, so now, so you can see I'm not even able to autocomplete the script now. Well, why is that? It's because I didn't even enable Python on this device. I need to go configure private, set system scripts, language, Python, set system scripts, op file, helper.py, commit and quit, and now I can have that autocomplete if I hit tab, and it will actually search through the help now. So yep, we found this example. So we can just use the help here to walk us through exactly what that second step is. So this tells us exactly everything we would need to know about setting up an external BGP connection. And then we can still use that help apropos script to get through everything. So let me just see if I can, so help topic. System. Yeah, unfortunately, so there is a way I can change the script so that it will look through everything. The problem with that though is it will greatly add to the runtime, and by greatly I mean it's already taking probably 30 seconds to run. It could take it 5–10 minutes to run if I do that. And it would be a lot of extra coding. So there's the obvious benefit. I need one less input to my script. And then, of course, if I use the wrong inputs, I won't get my results. So I have more of a chance to get the results that I'm looking for. So there's obvious benefit, but there's, of course, drawback where it's just going to be more code. It's going to be harder to memorize for use on exam day. It's just got plenty of disadvantages as well as advantages. Because what I can do is CLI help. So I can do, instead of that, I can do help topic. Question mark. And of course, pipe no more. So of course the, yep. Yep, and then I can recursively go through each one and do that same thing. So the next one would be help access. Yep, and then the next one would be help accounting. Yep, and then as long as I see a, yep, and then I would just keep going down the line, mobile IP, yeah, chap secrets. Yeah, and then yeah, so this is what I could do. I could have it recursively go and do this question mark and just have a huge list of every single help topic. And then I can search through that giant list for what I'm looking for there. So it would be a kind of my own grep, but it would go for everything. It wouldn't just be for the particular section I wanted to look for. But that would save me the problem of having to know what section I want to look for one. And it would yeah, so I would really like to do that. Um, it's just in this video, I think I'm on the right track. So so I want to keep going. I'll do this as an extra video, perhaps, or if I've got extra time. I mean, the only reason I'm kind of hesitant to do this is I just don't think I have the time to do it. Okay, so they are giving me a sub ASs to work with. Okay, so I've got 1, 2, 3, 4 sub ASs. Okay, so looks like they're giving me yeah, so this is configuration for all devices in these sub ASs. So let's think about so we've got 4 sub ASs. So yeah, let's have router A and B be in the first sub AS, but then each of these will get their own AS. So okay, but before we do that, we are going to need Ebgp connections. But actually this will give us that. Oh, we actually need IBGP sessions as well. Let's use ISIS. So I've only got 9 minutes, and I've got a meeting right at 1, so I don't want to go over. So I think I'm going to configure ISIS on router 1, and then that will be the end of this video. Okay, and I will need a loopback address because I need a family ISO on it, but I'll just set the I'll just set up the NET address and not worry about the INET address for now. I kind of just make the whole thing once. There we go. Oops. Oh, I need address. Okay, so now. Okay, so that didn't take too long. I think I do have time to set it up on router B. That'll be better anyway, because then we can verify that an adjacency has started. Okay, so we'll see if the adjacency comes up. If it does, I will stop the video. If it does not, I will stop the video because I'm out of time. Oh, and we're forming both level 1 and level 2 adjacencies. I think that's going to be fine. Actually, you know what? I might as well disable the level 1 adjacencies. I'm pretty sure they're going to require that on the test because that's just the way it's meant to be. I've got 6 minutes right now, so I'm going to use that to my advantage here. So set interfaces, protocols, ISIS, interface 0, 0, 0, level 1, disable. Commit and quit, and then we'll do that same thing on router 1. Set protocols, ISIS interface 0, level 1, disable, commit and quit, and now we should only have a level 2 adjacency between these two. So yep, it looks like the level 1 adjacency is down. So that just means, of course, that it's no longer receiving any hellos. So once the dead interval, hold timer, that sort of thing expires, we'll see that completely disappear. So it should only be a few seconds. So I'm just going to wait and watch that. And then once that happens, I will end the video. So yeah, you can see with the level 2 adjacency, the hold goes down to 6, and then it goes back up to 8 because it's getting a hello. The level 1 adjacency isn't getting hellos anymore, so the hold went all the way down to 0, so it goes into down state. But there we go. So now the dead interval, it expired. So once the hold timer goes down to 0, it starts another timer. The dead timer means the connection is dead. And once that's decrementing, you'll just hold it as a down connection. But if it decrements all the way to 0, it's not even worth holding on to anymore. It's not going to come back. So it just cuts it as we see there. All right. So thanks for watching, and I will see you in the after work video. Actually, I'm actually tempted to pause the recording because I've got an extra 15 minutes. So yeah, I think actually what I'm going to do is just pause it, and then I'll come back after my meeting and take the extra 15 minutes, and then I will see you in the after work video after that. But yeah, I can use that 15 minutes really well because I can finish configuring ISIS on the other routers. So I will pause it, and I will see you after my meeting. All right, so I am back. Oops, and it looks like, let's see here. So it looks like I am recording audio, but I just have my video stopped. So, all right, I should have my video started. I'm going to stop it again because what is behind the door that you constantly look at by merit of what my screenshot is, is something I would not like to show off too well. Okay, so those doors are closed for a reason. That is my bathroom. All right, but the door is closed now. So we've got, so I wanted to finish the ISIS configuration on all of these. We won't need any level 1 connections, only level 2. So Yeah, I'm just looking for like a dead interval. I don't see one. But anyways, we got B done. Let's move on to C. Oops. I don't think you have to add the loop back to it, but I'll just do it. No harm, no foul. Okay, so we've got a level 2 adjacency to the router B. Let's move on to router D. All right, so time for the last router. Oh, so we already got it up. It's faster than the other ones. Okay, so I think we're good. Let's take a look at the route table on router A. So we've got routes 1, 2, 3, and 4. Yep, and that's 1, 2, 3, 4. So those are all the routes. So we're all good. All right, so let's move on. Okay, so now we need a routing policy to advertise the BGP routes, but before we have that, we're going to need to set up our Ebgp neighborships. So we'll just follow along with this guide here. So we're going to have two Hmm. Okay. Okay, so for all devices in sub AS 65412, we're going to be adding this configuration. Okay, and then we're going to have a border device. You know what, let's make this a bit simpler. Let's just have two sub ASs, and then we'll have two confederations, Confederation 1 and Confederation 2. So, and we'll use sub AS 645001, or no, we'll use 655 65001 and 65002. So let's set that up on the so we've got a device that is yeah, that is a border device. And then we've got devices that are not border devices. So since we've got an odd number of routers, we're going to have 3 and 2. And we're going to have 2 border devices. So it's not going to be an even number. So we'll have C and D be our border devices, and then one confederation will have more routers than the other. Yep. Because, so what determines the number of devices in your confederation is that full mesh requirement. So we can't just have 4 devices in one configuration and 1 in the other, unless those 4 devices are wired in a full mesh. So that's how you can determine which devices are and which devices are not a part of a sub AS by their wiring. So in our topology, we've just got 1 wire. So I think we're going to have each router in its own AS. Another thing we could do is have these 2 in an AS, these 2 in an AS, and then this in an AS. But we could not have these 3 in an AS, and then these 2 or these 4 in this one, because this would not meet a full mesh requirement unless there was an extra link between A and C. So all of your sub-confederations have to be wired in a full mesh. So our only options are either having a sub-confederation for every device, or having 3 sub-confederations, 2 of them containing 2 devices, because these are in a full mesh, and then a third one for the remaining device since we have a odd number of devices. So I think 3 confederations might be a bit simpler to configure than 5. So let's do that. Okay, so let's start by configuring router A. And we'll just start by setting the routing options. And I've already kind of gone over my 15 minutes. So let's just do this and then call it good. Okay, so this is the first Okay, and then on these 2 routers, we'll have 2, and then the final one will have 3. And then I really will need to end this video. Okay, so this is going to have 2. Oops. All right, and then this one gets its own sub AS because we don't have full meshes between any 3 routers, so we can't. So we're limited. All right, but that's the end of the video. Thanks for watching, and I'll see you in the next one.